presentation on Slinky science. So to start out, I have two jumbo Slinkies that are slightly different sizes. You can see that the Slinky on the left is shorter than the one on the right, and it's actually narrower too. It can completely fit inside the one on the right. So what I'm going to do in a second is I'm going to release both these Slinkies down the stairs at the same time, and we're going to see which one gets to the bottom first. So right now, I want you to make a prediction. Which is going to get to the bottom first? The smaller one, the bigger one, or both at the same time? Alright, before I do that, I want to point out that both these Slinkies have remained stationary, and neither one of them have started moving down the stairs yet. And this can be explained by Newton's first law of motion, which states that an object at rest stays at rest unless acted upon by an outside force. So now when I release them, they're going to be acted upon by gravity, which means that they're going to start moving, and the potential energy is going to get converted to kinetic energy as they move down the stairs. So now I'm going to release them and see which one gets to the bottom first. So we see that the smaller Slinky made its way down the stairs way quicker than the larger Slinky. And this is because the speed as it moves down the stairs depends on two factors. It depends on the tension and it depends on the mass. The smaller Slinky had a lot smaller mass and the tension was a lot more compact, so it moved down the stairs a lot quicker. And we had an example of waves here where we saw longitudinal waves as the kinetic energy was transferred from coil to coil going down. And that's what caused the Slinkies to move down the stairs in that motion they did. And we couldn't really see these waves because it was longitudinal and it was going in the same direction as the gravity. But now what we're going to see is a Slinky that has transverse waves instead of longitudinal waves, and we're going to be able to see the waves. So I have here a smaller Slinky, and I have one end attached to the railing, and I'm going to hold the other end and move it up and down, and we're going to be able to see the waves. So I'm going to take this end, move it vertically, and you're going to see the transverse waves. See how the waves are moving up and down? You can visually see them. As opposed to the Slinky, you couldn't really see the waves. And again, that's because the gravity of the Slinky is moving in the same direction as the waves, whereas in this one, the gravity is moving vertically and the waves are moving horizontally. So you can actually see the waves move through the Slinky.